Thank you very much for the opportunity to present this afternoon. I'd like to build on what Marit, the previous speaker, discussed, the fundamentals, and cover two main topics. The first being some of the more practical questions for and regarding malolactic fermentation, practices that can make it easier or more difficult to manage the process. And the second topic is I'd like you to think about malolactic fermentation in a slightly different way, seeing it as a tool not just to do the fermentation, but actually to enhance the quality and the sensory profile of the wine. So maybe let's start by looking at some numbers. What is considered a good environment for the bacteria to do the malolactic fermentation? Temperature-wise, they prefer around about 20 degrees Celsius. Alcohol, preferably less than 13–12%. Not a lot of sulfur. And then, of course, the magic number, the pH, around about 3.4 to 3.5 and above is considered relatively easy conditions for the bacteria. I'd actually like to add two parameters to this, sometimes not considered as often, but it's also very important to understand what happens with the alcoholic fermentation and the impact it has on the bacteria. So ideally, you want a smooth alcoholic fermentation, not too fast, not too slow, and of course, not too stressed out yeast. And very important, and this is probably one of the parameters not considered a lot, is you need at least 1.5 to 2 grams per liter of malic acid to get the fermentation going and supply enough substrate for the bacteria to do the fermentation. Of course, two things, these parameters are very interconnected. In other words, they will influence the others. And secondly, the bacteria strains do differ quite significantly in how they are able to manage these parameters. So it's not set in stone, but it's a good guideline to work with. When you have these numbers, they can actually give you quite a lot of information. Especially the pH will give you a very good indication of the kind of bacteria that will be present, the kind of spoilage bacteria that could potentially be present. Of course, when you know what parameters you are working in, you can actually select bacteria cultures that are able to manage those parameters. If the conditions are more difficult, you could potentially consider adding a nutrient for the bacteria and maybe including some acclimatization steps before you inoculate. Of course, only if you know the numbers, you can potentially adjust them. And these numbers will give you a very good indication of whether MLF is even at all possible in the wine. So Marit briefly touched on some of the factors that can influence the bacteria and the fermentation. For the main parameters, the best practice would be to measure them, to adjust them if at all possible, and of course, to keep an eye on them and monitor them through the process. I mentioned that the yeast you select is quite important as well. The compatibility between the yeast and the bacteria, because as soon as you have a stressed yeast component, you have other metabolites being produced. Some of them, like the fatty acids, could be detrimental to the bacteria, and you may need to treat the wine to remove some of these if it's necessary. Fungicide residues, from the research, it's shown that mostly those used for botrytis sprays seem to be more challenging for the bacteria. And the best practice here is to actually respect and adhere to the withholding periods that the supplier will be able to give you. Something that's more problematic in larger volumes, larger fermentation volumes, is compaction. And here the best practice is just to make sure that you keep the bacteria and the nutrition and the substrates in suspension so that they have access to it. Least contact, similar to the yeast, the bacteria also is stimulated by the release of amino acids and vitamins. So this is also a practice that's well known in barrel fermentation to stimulate the bacteria. I mentioned the nutrition earlier. It's something that is not always needed, especially if you're talking co-inoculation conditions, not so challenging, but this becomes more important when sequential inoculation is discussed. And it's important to know here that just adding some more DAP will not solve the problem. The bacteria actually don't use inorganic nitrogen as a source, so you need to add bacteria-specific nutrition if the conditions are extremely challenging. Oxygen, the bacteria actually like a little bit of it, and we will a bit later in the presentation have a look at microoxygenation and how that influences the fermentation and the bacteria. Polyphenols is actually kind of a subject by itself. There's so much research being done on it, and it's very contradictory in some senses because it's very dependent on which type of compound is present, how much there is. The strains, the bacteria strains differ quite a lot in terms of their tolerance. Of course, you've heard of the Merlot factor, and so there's a cultivar influence. And from the research, it seems that the condensed tannin seems to be more problematic. And later on, we'll actually have a look at what the impact of some of the allergic tannins are on bacteria and malolactic fermentation. I'd like to take just, because this is the practice here is very simple. The rehydration step of the bacteria is not actually a rehydration as we know it for the yeast. It's really more of a step where it's just so that the bacteria can be dispersed more easily. And here you pretty much have one practice. Follow the instructions of the supplier. If they say don't use tap water, don't use tap water. If they say 10 minutes, then use a watch and time 10 minutes. So here you really have to follow the instructions because that will ensure that you have the highest active population of bacteria when you inoculate. Okay, so now you as the winemaker have 4 major decisions to make. First, you have to decide if you actually want malolactic fermentation in your wine. So some wines, in terms of a stylistic point of view, won't need malolactic fermentation or you don't want it, whereas other wines really benefit from it. So you have to decide that. Of course, once you decided that you want MLF, are you going to wait for it to happen spontaneously or are you going to inoculate? And if you're going to inoculate, the 2 biggest questions become when are you adding the bacteria and which bacteria will you select to do the fermentation. So first, as I said, really from a stylistic point of view, you have to decide whether you want malolactic fermentation or not. Some wines benefit from retaining the acidity. Think a very style-driven Sauvignon Blanc style. It's not something you want malolactic fermentation in. Whereas other wines, maybe a Chardonnay or maybe a greener type of red, can really benefit from the sensory impact of malolactic fermentation. Softening of the wine, less green characters, more complexity, more fruitiness. So here you really have to decide which impact you want in the wine. As I said, the second question then becomes, do you want to inoculate or do spontaneous fermentation? Of course, spontaneous fermentations raised a lot of questions. How long is it going to take? Which bacteria will actually do the fermentation? What will be the impact on the aroma, on the quality? And of course, if it doesn't happen spontaneously or the wrong bacteria is present, what does that mean for your quality and also for restarting the malolactic fermentation? Of course, if you decide to inoculate, that addresses many of these questions because you have a known duration, known sensory impact, and of course, a lot less risk involved. And this is up to you as a winemaker to decide. Okay, so you decide you want to inoculate for malolactic fermentation. When do you actually add the bacteria? So you have a couple of options, and probably the two most important is co-inoculation and sequential inoculation. So the co-inoculation can be anywhere from 0 to 48 hours, where you add the bacteria together with or after the yeast, and this will differ between different suppliers. And then there is a very big difference between the sensory impact that you have with co-inoculation and sequential inoculation. So it's important to decide what you want in the wine at the end of the day. One of the biggest differences, of course, is the difference in the duration of the process. Co-inoculation, obviously, alcoholic and malolactic happening at the same time. Less risk of spoilage. As I mentioned earlier, in most cases, you don't need nutrition in co-inoculation. And probably one of the biggest differences is that with co-inoculation, you naturally have lower levels of diacetyl. So definitely less buttery characters coming through and more of a fruit-forward kind of style with co-inoculation compared to sequential. Okay, so winemakers, things have changed a lot in terms of what is available to choose from as a bacteria culture. And I'd like to go through kind of how things have changed, how we used to select bacteria cultures, and where I think the selection process will go in the future. So originally, it was really, does this thing do malolactic fermentation? That was the only consideration. I just want the fermentation done, and I want it done as fast as possible. Okay. Then what happened is things didn't always go as planned, and we started to realize that the bacteria actually have different needs, different nutritional needs, different tolerances for pH, alcohol, etc. Then came all the rules and regulations and the export expectations and the documentations and the certifications and the audits, specifically with regards to compounds like biogenic amines, ethyl carbamate, etc. But now I think we're finally moving to a place where we can talk about bacteria in the same way as we talk about yeast. The fact that it does the fermentation is a given. Now let's discuss the actual impact on the sensory profile that the bacteria can have, whether it be increasing structure or fruitiness or spiciness or mouthfeel. So ideally, we would now like to get to a point where we see bacteria also as a tool to not just complete the fermentation, survive the wine conditions, not produce biogenic amines, but actually enhance the sensory profile of the wine to reach a certain style. Fresh and fruity, wines for aging, structured wines, etc. Okay, so what do we have available to do this? We now have selected and characterized bacteria cultures. You have three main types of cultures, single Inococcus uni strains, like the Solar range from Anchor and many other suppliers, single Lactobacillus plantarum cultures, which is 100% plantarum, and then like the duet range from Anchor is actually a blend of those two main bacteria genera, blend of Inococcus uni and Lactobacillus plantarum. Okay, so for the next part, I'd like to just address some of the more practical questions I come across when I talk about malolactic fermentation with winemakers. Questions like, can I do co-inoculation if I'm using tannins? If I'm doing microoxygenation, what implications does that have for fermentation? What is the difference between co-inoculation and sequential, and the impact on my wine? And of course, a favorite question is, are there actually any differences between commercial bacteria cultures? So as far as tannin usage goes, as I mentioned earlier, the condensed tannins seem to be a little bit more challenging for the bacteria, but we have shown that taking a culture for co-inoculation, here you can see with and without tannins. Even when we use tannins, we seem to increase the total ester concentration. So there's actually no negative impact, the opposite actually, a positive impact of using tannins during co-inoculation. Of course, does that actually pull through to the sensory aspect of the wine that a tasting panel can pick up? Here on the left, we have a blended culture with and without tannins. And you can see that as soon as we use tannins during the co-inoculation fermentation, we have better quality, we have better color intensity, better fruit profile, some spicy characters. And the same is true when we use a different culture with and without tannins, that we can actually enhance the quality of the wine. Many winemakers ask, what is the impact of co-inoculation on the color? What does that mean? And also, can I use microoxygenation in the same space as co-inoculation? So what we did is we compared two treatments, a malolactic fermentation in sequential conditions with and without the oxygen, and malolactic fermentation in co-inoculation with and without the microox. As you can see, first, by just comparing co-inoculation with sequential, you actually have a higher total color intensity with co-inoculation. Then, when you compare the co-inoculation treatments with and without oxygen, you have the highest total color intensity when you use co-inoculation with the blended culture with microoxygenation. So there is absolutely no risk in using techniques like adding tannins during crush and during fermentation, or using microoxygenation during the fermentation. To the contrary, it's actually really quality enhancing benefits. Question I have, what is the impact on color? So we looked at the anthocyanin concentration, and here we specifically compare two blended cultures in co-inoculation with two single Inococcus uni cultures in sequential, and clearly there is a significant increase in the anthocyanin concentration with the co-inoculation compared to sequential. So what happens if we compare different bacteria cultures in co-inoculation? So the two blended cultures, duet aroma and duet soft, in comparison to the two gray bars, which is two Inococcus uni cultures, you can see that there's an increase and a positive impact on the color intensity and the anthocyanin concentration when you use the blended cultures. So no negative impact of co-inoculation on the color in your wine, and even better results when you use a blended culture of Inococcus uni and plantarum on the wine color. So the reason we have a blended culture in the first place is because Lactobacillus plantarum is actually naturally more complex in terms of their enzyme profiles, as Murray described. And here you can see the Dueta Rome culture has a Lactobacillus plantarum strain that has beta-glucosidase activity. So what that means is, in comparison to a single Inococcus culture, you have the ability with the blend to actually release more grape-derived aroma compounds. So they're bound and not volatile in their form from the grape, and when you add the bacteria with this enzyme activity, you can actually release more of these monoterpenes, norsoprenoids, really the compounds that enhance the fruity and the floral characteristics in the wine. And this is why you would use a blend as compared to a single culture. Same thing, this is a different blend, but once again, you can use the bacteria as a tool to enhance the fruit profile of the wine or enhance the quality of the wine, as you can see on the graph on the right-hand side. So a blended culture in comparison with a single Inococcus culture. What happens when we compare two blends? So as I mentioned earlier, the strains, the bacteria strains, don't just differ in their tolerances of pH, alcohol, sulfur, etc., but they also are different in how they impact the sensory profile of the wine. So here you can see in the blue bars at the top, the Duet Rome culture very much driving the fruity aroma profile, and the Duet soft culture, the green bars in the bottom descriptors, much bigger impact on the tannin intensity, mouth feel, and volume of the wine. So by using different strains and different blends of bacteria, we can actually decide what way we want to go with the sensory profile of the wine. This is not only true in co-inoculation conditions. You can see the same thing happening in sequential. Here we focused on comparing the Inococcus uniculture Solo Select from Anchor versus another commercial Inococcus uni strain. And you can see that you can actually use the bacteria as a tool to enhance spiciness or fruit characters, but also the overall preference that tasters have for the wine. Okay, so hopefully this answered some of the more practical questions with regards to bacteria and the winemaking practices you use in the cellar, what can actually enhance the bacteria and the malolactic fermentation, and the aroma profile and the quality of the wine. Okay, so choices. You as the winemaker have to make. Of course, do you want malolactic fermentation? What are the parameters that you have to work in? And then decide what you're going to do in terms of inoculating and which bacteria cultures, depending on what you want to achieve in the wine. If I have to summarize the best practices, I would really say, number one, decide what you want. When I say that, I mean decide what kind of impact on the wine aroma you want, what kind of style impact you want, and be very clear about where you want to end up with the wine. Of course, be very respectful of what you have to work within, be it analytical parameters. Do you have cooling in the cellar? Do you have heating in the cellar? So be very clear about what you can and cannot do. As I mentioned, some of the factors that will influence the bacteria, be aware of them. And it's so important that I made it number 5, 6, and 7. Just as you would manage and monitor alcoholic fermentation, you have to manage and monitor malolactic fermentation. It's only by doing this you will, number one, understand how your winemaking decisions using tannins or microbes will influence the bacteria and the fermentation, but also you will realize how you can actually use bacteria and malolactic fermentation as a tool to reach the objective you set in number 1. So hopefully this answered some of the questions you have, and I would just like to thank the organizers, and thank you very much for the opportunity and the invitation to present today. Gracias.